Okay, we are back with a question from the Polynomials, Exponents, and Radicals problem set, and specifically we are going to look at question number 23. This question says, which trinomial is equivalent to, and we have a rather lengthy, unsimplified polynomial expression. And all of our answer choices are in standard form, and they look like they each have 3 terms. So we're going to need to look at this expression and decide how can we simplify this. The first thing that I notice is that we have a portion of this expression, specifically this x minus 2 quantity squared. This often gives students some trouble. What I often see is that students will take this exponent and try to distribute it across subtraction or addition, whatever happens to be in the parentheses. And we, of course, cannot do this. This is not allowed, illegal. No, we cannot do this because we would be violating order of operations. In fact, inside this green box, what we have is a quantity squared, and we will need to actually expand this expression out. So what this really means is x minus 2 multiplied by x minus 2. And you'll notice that sitting just outside, we have a coefficient of 3. And so what this is saying is we're going to take this entire phrase and multiply it by 3. And outside here, we've got this minus 2 times the quantity x minus 1. And we'll look at that a little bit later. Okay, so let's deal with this expanded expression in green. What we're going to need to do is multiply this binomial carefully. Notice we've got x being multiplied by another x term, and x multiplied by a negative 2. So this will be x squared and negative 2x. Then inside the second term, we have a negative 2 multiplied by an x, that's negative 2x, and a negative 2 multiplied by negative 2, and that will be a positive 4. Okay, keep in mind this entire thing is now going to be multiplied by 3. Okay, let's go ahead and look inside the brackets and see if we can combine any like terms. I notice that I have a negative 2x and another negative 2x, so I can go ahead and combine these like terms. So I'm going to do that real quickly. This is x squared minus 4x plus 4. And all of this is multiplied by 3. And outside the brackets, I have minus 2 times the quantity, x minus 1. At this point, we can go ahead and distribute our multiplication. So this will be 3 times x squared, that's 3x squared. 3 times negative 4x, that'll be negative 12x. And 3 times positive 4, which will be, of course, positive 12. And now we can go ahead and address that minus 2 times the quantity, x minus 1. Something that we have to be really careful of here, specifically if we've been writing this work on our own, is to make sure that this negative sign stays with the 2 and the multiplication. So this is saying take negative 2 and multiply it by x. That'll be a negative 2x. And take negative 2 and multiply it by negative 1. That's a positive 2. That tends to be where most mistakes are made here. The sign change. Negative 2 times a negative 1 makes a positive 2. And now we're just going to look for any like terms that we have and go ahead and combine those, and then we will have our simplified expression. So I notice I have a negative 12x and a negative 2x, and together that'll give us a negative 14x. Those are found in answer choices 3 and 4, so I'm going to go ahead and eliminate answer choices 1 and 2. Next, I'm going to take a look for any other like terms. And I notice that we've got a positive 12 and a positive 2, so those will combine to give a positive 14. And at this point, we can eliminate choice 3 as well. And of course, we notice that we've got our 3x squared as the first term in the polynomial, and that appears in our work below. So more than likely, if students make a mistake here, it tends to be up here with this exponent. We need to make sure that we expand this out properly. And the next spot that tends to give students trouble would be right here, this negative 2 times a negative 1. This tends to lead to a sign error. Otherwise, just take care to combine your like terms carefully, and you should be good to go.